Hello, everyone. Good morning, good afternoon, good evening from wherever you're joining us. My name is Dalia. I work as a global community manager here at Kong, and I'm so happy to welcome all of you here for our April user call. The topic for today is custom plugin development with Kong Gateway. We have Lokesh here with us. He will introduce himself. Let's take all of the questions at the end. There is a Q&A function where you can post all of your questions. We will answer them when he's done presenting. And yeah, that's all for me. Go ahead, Lokesh.
Thanks, Dalia. Hello, everyone. So my name is Lokesh. I'm a senior engineer at Kong. I primarily work in the customer experience team. I also work as a solution architect into more enterprise and strategic customers, primarily on the UK financial services domain. And also I help engineering team to develop plugins as well. And that's why I'm here. Okay, so let's get started. Let me go to the agenda first. So I know we have a packed agenda, so I'll try to cover as much as smoothly. There's a lot of technical details around it, and there would be a demo at the end as well. So we will touch base initially with the with some high level understanding around Kong plugins. Also some know-how around why we need plugin, what it is, how does it integrate with the Kong Gateway. Bit deep dive into how Kong Gateway on the runtime integrate with plugins. Touch base on the development tools. We work with a lot of engineers, and we build some in-house tooling as well. So that's something to help. Some installations around how we install the custom plugin onto the Kong Gateway. And this another one is much debated topic around having a plugin in different programming language. So we will we'll touch base that area as well. At the end, we will wrap up around the demo and some best practices around point of view from the field side. Okay, so let's move on. Introduction. So before we go to the introductions, let's take a step back and understand the runtime, so understand the overall what Kong it is. So that gives us, when the plugin is running on what foundations. So to start with Kong as an applications, which is primarily written in Lua, and that's on top of OpenResty framework. And which runs on the Nginx web servers. That's primarily, in a nutshell, the tech stack behind the Kong. It's very important to know that because, when we write the plugin, so that we can make a mindful choice around what technology we choose when we write the plugin. Going next, I'll give a brief introductions around the Kong modular architectures. Again, why it is important, it is to understand where the plugin fits and what its life cycle. So, as I said, the core motherships for the Kong is Nginx and OpenResty. In fact, the Kong is a primary, major contributor for the OpenResty. And these two technologies base the foundations for the Kong, all the underlying architecture side on these two technologies. OpenResty provides the nice, why we use OpenResty, because this provides the nice hooks around the response and request lifecycle, and this is where the Kong plugin comes into the picture. We do have the Kong clustering and data source. This is around the Kong config management and around the caching. Of course, plugins. We will talk a lot more around these areas, but primarily you can write into many languages. The core use case around the plugin is to intercept your API request and backend API response as well. And at times customer use to integrate with the third party. And on the top, we have the administrator control plane, right? Controller where you can configure the plugin, configure the service and routes on various means. Okay, so let's zoom in around the custom plugin, why we need and what it is and how Kong supports, at the runtime to execute the custom plugin. So this is what, I work with a lot of customers, and one of the key question customer ask is, what are the, primary reason around the using the custom plugin. So the common use case we saw around the custom plugin is to, whenever you find a scenario which is or out of the box plugin doesn't support it, then you go and implement the custom plugin. There are areas where we don't ask the customer to go wild, just, don't implement your integration pattern into the custom plugin, but rather, keep it like within the API gateway nomenclature. Sometimes customers also have their in-house third-party system where they wanted to implement this custom plugin. So that's quite go well. One of the things I'll highlight here is all our Kong plugins is present in the Kong image, and this is how the custom plugin will be also installable into it. We'll come to that point, but we have a lot of plugins in those areas around the authentication, security, traffic control, around the analytics as well. And you can find all these details into our Kong hub. Because on every new cycles there are new plugins coming in. Sometimes the community also participate to create new plugins, and that's updated on our hub. How it works. So Kong provides pretty flexible architecture around the extensibility. As I show you in the previous slide, having the open registry, it's very easy to hook up between the different Nginx modules. So that's where the plugin ecosystem fits in. And even 90% of our API gateway policy is work on the plugin itself. So plugins are the real muscles we are in the Kong gateway. Plugins also, if you write the plugins into Lua, it's run in process with Kong gateway. And I think from the deployment perspective, it's easy to deploy it. And since it's run in process, they are highly performance. There is no external process running when you write the plugin into Lua. So it's a quite tightly integrations within the Kong gateway, given its modular architectures, so that you can hook up the custom plugin very easily. The life cycle of the plugins, which you can call as a scope, can be to a different Kong entity. I'm not going into detail around what is consumer routes and services is. I'm assuming you would have some knowledge around it, but these are primarily actor or primarily configurations details around the gateway around it. And then you can scope it down to a plugin to any level, which is globally or a particular consumer or particular route or service. And then the plugin will execute during that point of time. What plugin can do, again, if you think from the API management perspective, all the API policies which you need from based on your requirement, it is the Kong plugin who would be doing that, which is in area of authentications or security or traffic control. Transformations is heavily used in the plugin, and somewhere in the logging and analytics when you wanted to integrate with your in-house monitoring system. Right. So if that's give the overall idea around the how and what plugin can do. If we zoom in a bit, that what exactly the plugin, how exactly plugin it's hooked up within the runtime. So for that, let's understand a bit around the Nginx, because that's a very key technologies which Kong is based on. And then we'll go to that how the different phases are tied up with those different Nginx modules. So as you can see here, these are the Nginx, okay, open REST modules. So bit technical from our side, but then Kong will provide the very abstract level on top of it. So what it does is these all are phases, encapsulate within the request phase. And then the content by Lua is primarily, come under the response phase. And then there is a third phase, which is a log phase. We will talk about it, but that's primarily, anything to do with the logging and monitoring and etc. So this is how the, when we want to write a plugin, we need to understand that which particular Nginx module or directive we need to apply for the request, and we need to have that mind for the response as well. Something to note about it, and that's again, I've seen the customer, they made mistakes around, which particular, the Nginx module directive works at the application level, and what are the rest of the directives, what works at the request level. The reason being that, because anything you wanted to do at the bootstrap, right? So for example, if you wanted to initialize a plugin with, loading some environment variable or updating your cache, ideally we should do at the application level. And of course, the request level is, being executed on each and every request. So that's a very use case around, loading the environment variable or cachings during the application bootstrap, because you don't want to, load every time your request and response comes, because there is no use around it, and it also creates the performance overhead. So going further, if we actually mapped out to these different directives to the actual, the plugin methods which provided by Kong PDK, then what it looks like. All the initializations directives, which is primarily, create hooked up in the init worker. So anything to do with the initializations, which is just, once in a life cycle, when Kong data plane bootstrap it just, execute the init worker. Anything with respect to your client request, you want to read some header, or you want to change a header before the request go to the upstream. These are the phases you will be you'll be dealing with. The one of the main, most frequently used the method is the access method, where you can deal with the HTTP header, the request body, and if you want to enrich something or having some business logic around it, that works quite well. And then the last one, of course, not second last, around the response. So once your backend API in Kong world we call as upstream. So once your upstream return the response is again, come to the Kong, and you wanted to do something into it, like enrich that response, or add some identifier, or add some correlation ID, etc. Then that's something you would be doing with primarily in these two methods. As name suggested, header filter deals with the header only, and the body filter can deal with the header and body as well. So if in Kong, what we do is we crave around the performance. So anything to do with the header, Kong will not open up the body. So it's very lightweight operations. You just change some header here and there and send it back to your API client. So if you know that you only need to do any, change something into header, I recommend to just use the header filter rather than going into body, because reading the body is again, you are opening up the entire HTTP request body, response body. And then this one around the logging, quite handy, is when you want to log something into it, for example, getting some IDs from the HTTP header, and you want to log inside your log file. The good thing about this logging phase is it execute when the last response byte sent to your API client. So there is no latency being introduced in the login phase. You can just say that it works as asynchronously. It's not asynchronous, but it just works after your response being delivered to your API client. Right. So that's all about when we write the plugin and when we have a requirement, we can just map it out that which method or which phase I need to write my custom logic. Now, when it comes to the plugin, when we develop the plugin, there is a certain structure which we follow. Kong asks you to follow around it. And then it's pretty simple, right? You have a handler.lua, which is your core module where all your business logic goes in. So all your methods would be implemented into the handler.lua, which we saw in the previous slide. It's a mandatory file, so you can't have a plugin code without handler.lua. I doubt you need a plugin if you don't have handler.lua. And then another important file is around schema. So the schema is very important where if you think from the product perspective, we make the plugin like quite generic, quite configurable, quite flexible. So that's applied to custom plugin as well. So when you create a custom plugin, make sure that it's a configuration driven. You can add as much as flexibility as you can, so that can meet your future requirement. The next three files, which is data access, object, Lua module, your API module, and migrations. So they are pretty much non-mandatory because that's based on use case to use case. So for example, if you need anything to do with your database, then you would need and you are looking to create some custom entities and custom table into Kong, then you would need this data access object Lua, and then of course you need to provide the migration file so that when Kong creates those tables, it knows what tables to create. And then the API.lua is you wanted to create an endpoint, right? Endpoint within your platform, right? Not your endpoint of your actual business API, but some certain endpoint you wanted to have from the platform perspective. Then that's where you will implement the API.lua, so it can create those endpoints. Go next. Okay, so now let's talk about the tooling, because once you know where my business logic goes, you figure it out and you build the plugin. I mean, you figure it out, okay, this is my structure of the plugin is, you would be looking around the tooling, right? What sort of tooling I need to adopt so that, that makes my life more easy. Pretty simple. We keep, from the Kong, we don't have any reservations around the ID because, it's a developer choice. But one of the tool we created in-house, which helps a lot around the testing of your plugin. So it's called Pongo. It's a container-based, it's a Docker-based. It provides you the integrated environment around the Kong. So you actually see the request is coming to running Kong, and then the response is going back. So it's provide you full integrated environment where actually, Kong is running within your container. It's follow the unit test. You can write the unit test so the Pongo can execute the unit test. It also provide the other features like, your linting, where it could go and, go and check your syntax, validations, etc. And also it helps you to package your plugin into ROG file. We will come to that in a bit later in the installation steps, but this tool also help you to package the artifact out of your custom plugin. It's publicly available, so if you search Pongo on Google, you'll find the link and you can start playing around. There is another one which we have created, and this is something we learned from our wider audience around to create a plugin template, which will give you a kickstart. It's a scaffold project, so which is already there. Give you a initial file structure, initial integration test, so you are ready from the day one, and then all you just need to do is flush out your business logic into it. Again, it's available publicly, so you can go and use that template. In fact, we will use this in our demo, so you will see in the action. Your local development for Lua, which is pretty much, we build the plugin in Lua itself. So there is no interactive debugger available, because Lua works as an extension of your existing language. So yeah, you have to live with it. You can also install Kong locally, because you can install with LuaJIT and LuaRocks. There are instructions available on our Kong Git, so you can find and do that. Of course, you need to update few parts around your embedded LuaJIT and LuaRocks. We don't ask you to install this LuaJIT separately, but it just comes with the Kong in its artifact itself. Around your IDE, it's your choice. There is no settings down around that. How do you want to use your IDE? But pretty much our engineer and we use the Visual Studio Code, but it's up to the developer what they want to do. There are a few VS Code extensions that you can use it, as I provide here, which can help a lot when you write a code in the Lua. Okay, installation. So if you see Kong, Kong can deploy it into many ways, right? You can deploy Kong in in a bare metal in your VM. Then you can just if that is installed, then you just pack the plugin file as a ROC file, because this is how within the Lua LuaRocks works. So you just package into the ROC file and use the LuaRocks to install that plugin into your operating system. If you use the container base, for example Docker, then in that case you just mount the plugin files into your Docker volume and just configure the plugin into your Docker file, or create the custom image and just deploy it. And if you deploy it as in Kubernetes, then the easiest way, which is my favorite one, is you can just create the Kubernetes config or secrets and change your Helm chart, and it just works like a charm. For our customer primarily, we recommend as a best practice to create the custom image. The reason is that because when you have a real-time scenario, when you have a specific customer, a business problem, then your plugin be a bigger, right? You need to have version control, etc. So that's where building the custom image can easily go with your image version, with your plugin version, so you can easily manage that one. And it also go with the your container concept around that. Everything should be packed inside your container. You should not have your the runtime or executable outside of your container. So that's why we usually recommend customer to create the custom image for Docker or Kubernetes based deployment. Okay, so going next. Again, a lot of customers ask around it. Okay, we have many plugins, and we wanted to, hook that up into our CI/CD pipeline. Have this a very simple point of view around that. When you have a custom plugin, how you can, continuously deliver or continuously update, if something has changed. Because I work with a customer where we build like sort of almost like 20 different plugins. Then you need to think about the automations, right? In that case, it works pretty simple. Nothing new from the development perspective. You have a PR, your PR review done, merge, and then you use the Pongo and just have the few command for the Pongo around the linting, around your test executions. Then at the end, you build the artifact, which is, build your your rogue file, etc. And then you just upload your artifact somewhere, as an whatever, artifact tree or whatever choice of the tool you have within the organization. Then while delivering it, you just get the artifact, build the golden image, and just deploy the golden image via Kubernetes or Docker, whatever means you are deploying it. Right. This is another, much debated topic around the custom plugin in other language. So far, what I've described is the one most of the plugins we developed into Lua, and that's how you package it up and you install and deploy into the Lua. But having said that, Kong as a company also provide other means of other programming language you can use to create the custom plugin. And for now, there are primarily 3 different languages supported: Python, Go, and JavaScript, where you would need an external process running at the same times, which we can execute your Go and Python plugins, and then you provide a hook into the Kong. Also, in our last summit, there is a tech preview coming in for WASMX. It's a very a huge feature will be coming up soon. We still need to decide from the product perspective is when, but that will open up for more area around providing, for example, Rust or any other languages. Even if you want to write in Java, you can write in Java, and you can provide this WASMX client. Yes. So this is when the more contentions comes around, like why Lua and why not the other language. The reason when it comes for the Kong plugin itself, because we're talking about the from the Kong plugin perspective, what we learned is it's not about learning the technology, but it's about learning the platform, learning the Kong, learning how OpenResty works, learning how the request phases and response phases works. So like most of the learning curve is around that ecosystems. And then also, learning the tools, right? How Pongo works, how my unit test case I write, etc. And then it's only 20% of learning the language. So that's why we say we just need to balance it out when you make a choice of the language. There are other advantages of the being right in the Lua is it has a native support. As I said, since Kong is built in Lua, it provides the in-process runtime for the Lua. So what that means is it's very well performant because there is no like a different processes running. It's again very well tested. There is a solid tooling supports around it, and also Lua has a smaller and very compact ecosystem. So you will. Sometimes it's hard to find the compatible driver, but think about it. We build the Kong in entire Lua, so I don't think so. You will end up with the situations where you are not having anything in the Lua from Kong perspective. The Go and the other language, you would need to run the external process. Of course, there is a larger library sets is available when it comes to transformation, and this is where the Lua slightly lag. lag is around the, if you wanted to read some XML and create the XML to JSONs, which again, I doubt why you need to do in API gateway, but if you have certain like complex business logic and you need a complex library, then you have a more larger set and available into other language than Lua. From Kong perspective, our tooling are evolving. We are working actively onto it to support a customer who wants to write the custom plugin into different language. And bear in mind, sometimes using plugins into other language than Lua can also add the performance overhead as well. Given one of the key differentiator is like the plugins in other languages run as external process, as again to Lua it just run natively. Okay, so right, demo time. What I'll do is I'll quickly run a short demo around, when you want to write a custom plugin, what's the first step you need to do, and how to deploy into my Kubernetes environment. So wish me luck. All right, let's do it. As I, show you on the previous slide that this is the template we have. So I'm using the same template. And what I'll do is I'll just create a new repository for this template. And I just say is my hello world plugin. And I can just straight away create the plugin from this repository. And it gives you everything, right? The structure you need, and its integration test and everything. Okay, so it has everything what we need. All I'll do is I quickly go and clone this repository. So I'll go into my workspace quickly. Right, and the let me open up my Visual Studio. Right, so as you can see, we have handler.lua here, which gives you all the hooks like init worker, we describe that, access, header filter, etc. So what I'm doing in this plugin is basically setting up two header. One is setting up the header into the request, which will be visible to your upstream. And also on the way back, I'm setting up the header into response, which is, go back to your API client. Pretty straightforward. But what this file does is give you like, kickstart around what you need to do in each and every method. Also gives it the schema.lua. If you see here, I'm just providing the name of the header. So like, hello world, bye world, So that gives you like, idea around that, how the configurations can be useful, because if you have requirement that, okay, I want a header name to be different, then you can go and change the schema file. I'm not changing anything into it. I will straight away go and deploy it. Before that, I will run pongo command. Make sure I have pongo. I would say just just to demonstrate that, it just do the linting of all your the handler file, schema file, as well as your the test cases. So as everything works, what I'll do is I will now do one Pongo run, which is basically run your test case against the Kong running into your container. So as you can see, it's actually spinning up the Postgres. It's also spinning up the entire Kong stack. Meanwhile, it's running. I will quickly go and show you what's my mainly the integration test look like, where it basically just says, for example, on the request, I just go and check there is a header, which is the value of this on request, and there is a header which is for the response. There is a header which is value on this response, and this guy, the Pongo, provides dummy routes and host where you can just say, okay, against this route and service, just execute my plugin, test cases. Pretty handy. You can, it gives you a very fail-fast opportunity to just, if anything goes wrong, if you have a good coverage into integrations, you can catch that in early stages. Right. Okay. So now I know I've created the plugin. Did my run my test case. I validated it's all worked fine. I'm gonna go and deploy it into Kong, because this is where your plugin will actually execute, comes into action. Right now I'm running my Kong into a Kubernetes environment, so I'll just create the config map to have all these plugins into a config map, and then provide some configurations into my Helm chart so that you can start executing into it. Okay, already here. So I will, and for that I need to go into the actual directory, so which is Kong plugins, and so I have my plugin here, and then the two files, because these are the two important files which we need into the config map. So I just say pig create config map, just to make sure that I have the name right, and I'm creating the config map of my header, and from the file, which is the directory, the my plugin, ECPC. Oh, it's already exists. Sorry, it's there in my it's there in my Kubernetes already. So I'll do is delete. And name of the okay, and right. Okay, and for that reason, I also had just created a Helm chart. So I just wanted to show you that what is that you want to do, because now you created the config map, which is present in your Kubernetes, but at the same time, so you need to instruct into the Kong so it can load into the config. So when it comes to the configurations, you can easily configure against the services route. So in order to configure within the Kong, you just need to make few entries into the Helm chart. I will just I've created a folder here. So let me go into here and let's see the and let me, I'll show you here. So, okay, so in the values.yml, it's pretty standard chart. I'm not touching back to other file, but one of the things which we need to remember, need to know is how to configure it. It's a very very easy way. All you just need to do is just add this plugin, and then and then all the config maps for the plugins you have into it. So if you have multiple plugins, it's an array, so you can create that. Yeah, this is it, and then we just go and deploy this Helm chart. Upgrade, and then yeah. Okay, I quickly have a look around my port. So I'm still bootstrapping it. While it's bootstrapping it, yeah, it's running. And I quickly go, and if I show you here, and let me create a few services here. So HTTP, I'll just use the HTTP admin API to create few services and the routes here. Okay, so yes, it says it already exists. Yes, interesting. Let's create the HTTP one. And then I create one more service, the HTTP pin. So I'm creating the route here. Okay, so right, so this is exist. Interesting. Anyways, and if I access to that particular endpoint, oh, it's already exist. I guess I was creating it before, so the plugins already exist on this endpoint. So if you see the point around it, the configuring the plugin, if you use the Kubernetes, it's pretty straightforward. If you go into the Helm chart and update this particular particular plugin and the config maps, that's it. For your Docker or for your VM based, you can deploy the plugin into a different way. One way is to just mount that plugin into your container and just create the custom image. All right, so going back to my presentations around it, the last bit I wanted to cover is around the best, what are the best practices around it? Because a certain time the customer asks, and even the developer asks, anything I need to know in order to know like what could a plugin look like. So there are a few general rules around it. Say if your script, which is a Lua file, the handler.lua is becoming too big, you can just separate it out into different modules, and then you can refer into an individual file. Another good housekeeping rules is make sure your plugin is mainly configuration driven, so that when it comes to more flexibility, or you wanted to apply a different configurations based on a different needs, then you don't need to go and change the code, but rather you just configure the plugin accordingly. If you see our OIDC plugin, it has almost like 100 sort of different configurations. Sometimes it goes out of the hand, but if you manage it nicely, put into a different component, then it works out very well. The another way, the common ask we get is, say, for example, if I wanted to have the new feature I want to have change in the plugin and I wanted to run side by side, then what we say is, just rename your new plugin so that they can coexist together. If you have the plugin with the same name, then they will clash with each other. The another one is to make sure that you rename the database table and cache keys so that you prevent the collisions. Around the testing, as much as your integration test, so that you can cover all your edge cases and any issues before deploying into your productions. And for that, Pongo can help you a lot. If you need a performance testing, use the tool like K6, which can just give you how performant your plugins is, because bear in mind your plugin can add the performance overhead and latency in your API call. There are a few things to know around performance. For example, if you need something to share between your different phases, for example, you need some sort of ID which is come as a part of request phase, but you need that ID to be, if your upstream is not sending back, but if you need that ID to be sent, that information to send back to your API client, then you can just create a plugin context and then you can share that object between different phases. Avoid the locks, because if you have multiple workers requests coming in, then it gets very, very easily where you want to do update something around it, and that happens primarily when you build a plugin which is deal with your database and caching and etc. Use Concache as much as you can when you deal with database, so that you don't need to go and read the database every time. And just leverage the Redis as a shared cache, because we have our PDK provide a lot of those functions where you can just go and talk to the Redis if you need it there too. Okay. Right, and then I think this is our plugin hub. Again, I took a snapshot a while ago. The list is growing fast, and you can go and look into our Kong hub for the latest and greatest plugin. Right, cool. That's the end of my presentations, and we can have a Q&A now for any questions you have so far.
Thank you so much, Lokesh. That was amazing. We have a few questions in the Q&A function.
Right. So I'll read out first. I'll read out Mac's questions. Yeah, I think the Lua against the question for Max is around the Lua is preferred language for writing plugins, and what is the performance overhead if we choose the plugins in the different language. The key advantage of the Lua, as I explained in my presentations, is just running in process. For example, the plugin written in Go or JavaScript, they run in separate process. So there would be when it does the runtime executions, it just need to rely on that plugin servers to give the detail around it. So there is I can't come into the number because it's based on how big your plugin is, what sort of business logic it. But there is a sort of a latency you will introduce when you don't use Lua. I hope that answers your question, Max. The next question from John is, where does this log write to? So the log writes to the Kong log file. So Kong creates the Nginx logs, so you can actually go and write into it. In fact, not just that, within the log, you can just write into your monitoring solutions, for example, into your Kafka or some other monitoring. You can easily do that. The point to note is that your log phase doesn't harm your request and response because it just executes after your response is delivered to your API client. I don't know who is this question from, but this is around the performance testing on a plugin. The way to see the performance testing of the plugin, which is wrapped around how you do a performance testing of your API. With the latest Kong release, it give you the start time and end time of the Kong plugin, so your custom plugin. So that's something that will give you an idea that around based on your non-functional requirement, how much it's adding up into your executions. So you should just adopt the tool like K6 or to just test your performance. It's a very good question, John. Where can I control the version of the Kong while running the test? The version of the Kong can be controlled. One is in your Helm chart, but one of the good practices around your version of the Kong, because if that's why we recommend customer to adapt the golden image, the custom image, so you can version your Kong image according to your plugin versions. So that works very well. Do you any real world numbers to show the performance overhead between Go plugin and Lua plugin? It's very tricky to comment on this one because we are talking about the custom plugin, right? And the custom plugins has your business logic. So to put in a perspective, say if you are doing some sort of like a transformations, like you opening up the request body and doing some sort of a business logic into the transformations, then it's very hard to compare how much the Lua will give you and as against Go. But one thing for the sure that Go plugin or any other plugin will add up over and above what Lua adds up. Like it's very hard to come up with a number because it's based on your infrastructures and environment. But key point is it just runs in a separate process, which makes it more easy that it will be definitely add up some overhead into it. There. Question from Maciek around the accessing the shared cache Redis. There are PDK available. You can go and use the Kong plugin development kit. So if you go into our document and they will give you a library to access the Redis cache. Yes, Pongo spins the mock servers. So you can actually change the Pongo Docker file if you wanted to do that because it's publicly available. So right now, I don't think so you can stop the response, but if you wanted to have your mock server, then something you can do within the Pongo Docker file. I know what you are asking about, John. Maybe you want to stub on the XML response, etc. So for that, you need to extend the Pongo. Is there any way to debug Lua plugin? Unfortunately, no, there is no debugger available for now. What we do usually is we just create a lot more test cases, and we just go old school style, add some logging around it to find out what is going on. can Kong plugin execute the external script? I would doubt why you would to do that, because the Kong plugin is all about your API request, API policy, and business, business logic. So if you want to execute a Linux script, I think you are on the wrong path, because that's primarily for your API request and response. Hope that's a question. Okay, so there are around your question, Martin, transforming request and response. So we have our open source plugin around the request transformer. You can go and read more about it. You'll get good material around how to use our PDK to do that. So that's around. The next question is are Lua plugin asynchronous? No, they are not. They are basically, have executing same request and response phase. So they just execute in the order which you configure. Yes, there is. The next question is around the unit test for the Golang. Yes, you can write the unit test for the Golang. If you go into our Kong, plugin development, where there is a link for this, developing a plugin into a different language, and there is a good material around the Go and JavaScript. Question from Ron. I'm reading it. Yes, Ron, you're right. Again, answering the same. Go, Python, they run into a separate process. So when I say optimized, you can optimize your business logics, of course, within Lua and Kong, within Lua and your Go. But in terms of your runtime performance between Lua and then any other language, Lua wins that argument. Okay, so are there any Lua libraries for soft? Yes, in fact, one of our engineer has written into it. So there is a XML, I think it's XML thread, and there is a SAML detection plugin being written by one of our engineers. So they have written